So now we're going to put direct and inverse variation together. That seems to be where people mess up. Direct variation by itself is good, inverse variation by itself is good. The second we decide to put the questions together, people forget which one's direct, which one's inverse, and how to find the constant and what the equation is, okay? This sheet is going to be a very, very good study guide for you. So my suggestion is to fill out this chart without me, stop the video, and then come back to see if you've done it correctly. So if you're unable to do that, then you can do it with me. So the equation, direct variation equation. So direct variation is direct. Remember, it's a straight line, so it's in that form y equals kx. So that would be direct variation. Y is equal to kx. That's the direct variation equation. So anytime I ask you to write an equation, what are you filling in? You're filling in k. So then now let's move down. How to find k? Well, let's look at this equation. What do I have to do to find k? I divide both sides by x, right? So I'm going to do it. You don't have to write this part down if you don't want to. If I'm trying to find k, well, to get k alone, I have to divide by x, right? So we find k by doing y divided by x. So that's a shortcut. Like, you can just take the x and the y, you could just do y divided by x, and that will give you your constant. If you can't remember how to find k, well, use the equation, if you can remember the equation. Remember, k is called the constant, spelled with a C, right? It's actually constant of variation. And I'm going to let this bleed right on into the other side because it's also called a constant of variation and an inverse variation as well, okay? For a graph, example of a graph, it has to be straight, and what does it have to go through? The origin. So we have to have a straight line going through the origin, just like that, straight line through the origin. Does it have to have a positive slope? No, it can have a negative slope. It could go down like this. As long as you have a straight line going through the origin, then it is considered a direct variation, okay? Inverse variation. Well, inverse variation, instead of doing y equals the constant times x, it's y equals the constant divided by x. So it's y equals k over x. So now down, how do I find k? Well, think about what I have to do. If I have y equals k over x, to get k alone, what I have to do is I have to multiply both sides by x, don't I? Right? So to get the constant, you have to multiply x and y together. So that's how you find the constant, okay? That's how you find the constant. Both of them, k is called the constant of variation for both of these. So you can just let it bleed on over to the other side. Now the graph of an inverse variation is a curve. And typically, they're in specific quadrants, but sometimes they don't have to be, right? So if I put a curve here, the other curve goes here. It will never hit the origin, okay? Unless I shift it, right? So like sometimes equations can be shifted and it might actually go through some places. It might actually do that. It might actually go through the x or y axis sometimes, depending on what the situation is, okay? So that's just one example, all right? There's several different examples of inverse variations, but it's always these two little curves in opposite directions. So now this bottom part, again, is just another, like, this whole thing is just a study guide for you, right? Given an equation, how do you know? Like, look at the form. What does it look like? Like, if I ask you to identify if something is direct or inverse, look at the equation. Direct variations look like this. Y equals the constant times x. Here are 3 examples, right? Notice y equals x, the parent function. That's also a direct variation, okay? Inverse variations are always y equals your constant over x. So you're trying to divide by x. Like, x will always be the denominator in an inverse variation, okay? Given a graph, we just did that. If it's a straight line, if it's linear, goes through the origin, guess what? Check, inverse variation, okay? Direct variation is always going to be this little curve, right? And if you have more than one quadrant happening, it's going to show up in the opposite quadrant, right? So here, if you notice, this is a negative positive quadrant. It's going to be in the other negative positive quadrant. Here, positive and then negative negative. So they go opposite of each other. This one's just showing the first quadrant. This one, the whole thing is shift. Notice the origin's right here. That's okay. The whole graph has just been shifted. When you get into Algebra 2, you're going to learn more about inverse variation and when you know if the graph's been shifted or not. It's crazy cool stuff, okay? So now if you're given a table, if you're asked to identify if a table is a direct variation or an inverse variation, what you do is you see if you can find a constant, right? So you divide by y by x, and you do this for all of the points, for many, many points. And if you get the same number every time by dividing y by x, guess what? In a table, you have a direct variation. Here, remember you find the constant by multiplying x and y together in an inverse variation, right? So you do this for several points, okay? You just keep doing that, and if you keep getting the same number by multiplying x and y together, then you're going to have an inverse variation. So flip it to the back, let's do some problems. So again, like before, I always suggest you stop the video, give these 3 problems a try, and then come back in, see if you've done them right. That's the best way to learn from a video. Stop the video, try problems, see if you got them right. All right, so the next one. Write each equation in the y equals form. Identify as direct variation, inverse variation, or neither. You can't identify if something's direct or inverse unless y is alone. So let's take a look at the first one. To get y alone, I'm going to have to divide by x. So then I get y is equal to 12 over x. So what do you think? Direct, inverse, or neither? That's in the form y equals k over x, right? So that one is inverse, and the constant is 12. Okay? Next one. To get y alone, I'm going to have to divide both sides by 8. And then, of course, the 8's cancel out, and you get y equals, well, 4x over 8. That can be reduced, right, to 1 over 2, right? So we could say that this is x over 2, but remember, we can also write that as 1/2 x. So again, this is direct, right? So this one's direct because we are doing, the constant here is 1/2. So a lot of you might have said it's y equals x over 2, and a lot of you might have been like, oh, that's division, it must be inverse, but it's not. Remember, in inverse, where does the x have to be? It has to be in the denominator, right? So remember, y equals x over 2, that's the same as y equals 1x over 2, which means that the slope or the constant is 1/2. So this one, direct. The next one, yeah, it's going to be neither. But to get y alone, remember, you're going to add x to both sides. You're going to get 3y equals negative 12 plus x, then divide everything by 3. So this is just going to be a regular linear equation, but it has a y-intercept. So we're going to have y equals negative 12 divided by 3 is negative 4. Remember, there's a 1 here, so it's plus 1/3 x. So this one is neither. And it's neither because it's a linear equation that has a y-intercept of negative 4. So just remember, that's in the form y equals mx plus b, and b is not the origin. So direct variation has to go through the origin. So the next section. The next section, pay very close attention to the fact that it says varies inversely on the first section, and then 6 and 7 is varies directly, right? They're going to have different answers. They're the same ordered pairs, different answers. All right, so let's take 4 and 5. You have to take the directions y varies inversely as x. When x equals 2, y is equal to 6, find the missing coordinates. You can't find those missing coordinates until you know what the equation is. So let's take inverse variation equation again is y equals k over x, right? Right now, we can't start with 3y because we don't know what k is. We have to find k. So if you look at this, we have to put the 2 in for x and the 6 in for y. So I'm going to say 6 equals k over 2. To get k alone, I've got to multiply by 2. Now at this point, if you're like, you know what, the shortcut in an inverse variation for finding constant I already know is to multiply an x and y together, then awesome. So I get here that k is equal to 12. So then my equation is going to be y equals 12 over x. So now I haven't finished the problem, right? All I did just now is I found k. You have to find k so that you can write an equation. The equation is the rule for this situation. Now I can go back up here and I can say, all right, I need to find the value of y when x is 3. So now I'm going to come down here and I'm going to put the 3 in for x and solve for y. So I get y is equal to 12 over 3, and 12 over 3 is 4, right? So the answer to this question is y equals 4. Okay? So to do the next one, you have to use this equation to get the answer, right? So in order to answer a question like this, you have to use the information up here to find the equation. Find k, and then plug in the stuff to find what you're missing. So this one says find x when y is equal to 8, right? So I'm using that equation, y equals 12 over x, because we already came up with it, right? I put the 8 in for y, because that's in the y spot. So I'm going to say 8 equals 12 over x. Now we can't solve for x if it's in the denominator. So what you have to do first when you have x in the denominator, multiply both sides by x. Multiply both sides by x. So we have 8x equals 12. Boop. If I divide both sides by 8 to get x, 8 doesn't go into 12 evenly, but that's okay. We can write it as a fraction. 12 over 8 can be reduced by dividing by 4 into 3 over 2, or 1 1/2. All right? So you can't find the answer to these problems until you have figured out what the constant is. So the answer up here, the problem up here, is going to tell you how to find the constant, or tell you what you need to use to get the constant. Okay? So it varies directly. Same question, except we're saying varies directly, right? So I'm going to start this problem. I'm going to write it up here. Varies directly means y equals k times x, right? Like this is the form of the equation. We have to figure out what k is first. A lot of you might say, all right, well, to get k, I know I have to do y divided by 2. But if you can't remember that, then just take that form and plug it in. We know, so right now I'm not really answering question 6. I'm just coming up with the equation, right? But I'm going to write it under question 6. So I'm replacing the y with a 6 equals, I'm getting this information right here, x equals 2 and y equals 6. So 6 equals the constant, which we don't know, times 2. To find the constant, you have to divide both sides by 2. And you get that the constant is equal to 3. Now that's not the y value, right? That's the constant. Remember, that's what goes here. So the equation we're going to use for this problem is y equals 3x. That's what we're going to use for 6 and 7, right? So this guy is the equation we're going to use. It's the rule we have to use to answer 6 and 7. So now take the 3 for number 6. We're going to take the 3 and we're going to put it in for x, right? So I'm going to say y equals 3 times 3. So you get y is equal to 9. And now I've answered the question. Number 6, the answer is y equals 9. For 7, we're going to take the 8, we put it in for y, and solve for x. So we're going to say 8 equals 3x. Divide both sides by 3 to get x. Again, you have a fraction. So you get x equals 8/3. It's already simplified, or you can say that is 2 2/3. And that is the answer to 7. If I lost you at any point during this, stop the video, go back, watch it again, or ask for help. Moving right along to 8 and 9. Again, if you think you're good, stop the video, try it, but come back to make sure you're doing it right, because these problems seem super easy, but sometimes people do some crazy things with them. Okay, so number 8, m varies inversely as n. When m equals 10, n equals 2. Write the equation. So I'm going to start this one with the basic equation. Y equals k over x. How did I know it was k over x? Because it said inversely. Now, how do I know which one's y and which one's x? The first one mentioned is always y. So I'm going to put that in the y spot. M equals the constant over n. N, whatever's mentioned second, is the x. Okay, so my form is going to be m equals k over n. You're going to use m and n instead of x and y. So now, take this information to find k. I'm going to put m where the 10 is. 10 where the m is. So 10 equals the constant over n is 2. Solve for k. You can't write an equation unless you know what k is. So I'm going to multiply both sides by 2. You get here, k is equal to 20. Well, that's not the equation. The equation is you filling in the k right here. So the equation is m equals 20 over n. So whenever I ask you to write an equation, the thing that you are doing is you are filling in what the k value is in the form y equals k over x. If I change the variables, the first thing mentioned is m, the second is y. The second thing mentioned is x. See if you can do number 9 on your own. All right, this one. Cost varies directly with the number of tubs of cookie dough. We're using C and T. So I'm not going to use y and x this time, but we know it varies directly, right? So varies directly. Remember, that's in the form y equals k times x because it's direct variation. If you forget, go back and look at the front of your table, right? Y equals kx. So in this case, instead of y and x, I'm going to say C equals k times t. So we've got C equals kt. What do I need to do? I need to find out what the constant is before I can get the equation. So I know t is 5 when c is 40. So I'm going to put 40 equals k times 5. Find k, divide both sides by 5. So you get k is equal to 40 divided by 5 is 8. So k is equal to 8. So this particular equation, you now put the 8 right there. So the equation is c equals 8t. And that's your equation. If I asked another question here, you would use that equation to find the answer. All right, numbers 10 and 11. Find 4 points that make an inverse variation equation true. I'm giving you the equation. I want you to find 4 points. Honestly, this question throws people all the time. It is so easy. We've already done this. I'm asking you to make 4 points. It doesn't matter that this is an inverse variation, right? So let's just go ahead, pick numbers for x, plug them in, right? So I'll do 2 of them with you, and you got to do 2 more on your own, right? So if I'm coming up with a point, give me a number for x, right? You don't want to put 0 in there because you can't divide 24 by 0, but let's think, what are some numbers I can divide 24 by? How about 2? If I put 2 in for x, well, what's 24 divided by 2? That's 12. So that means 1 point is 12. Let's try one more. Let's say negative 2. So we have negative 2 in there. So 24 divided by negative 2, oh, that's negative 12. All right, you can come up with 2 more. The only number you can't pick there is 0 because you can't divide by 0, right? Notice whatever points you pick, remember, this is our constant of variation. Look at it. 2 times 12, 24. Negative 2 times negative 12, 24, right? Things for x and y, I could have 6, 4. I could have 4 for x and 6 for y, right? Things that multiply to give you 24. 8 and 3. Negative 8, negative 3. Okay? Just taking numbers, plugging it in. Do number 11 on your own. You can do that. Come up with an XY chart. Give me 4 values. If you can't do that on your own, stop the video. Come ask for help. All right. Only moving right along if you actually did go and come up with 4 points for 10 and 11. If you don't understand how to do it, you really do need to ask for help. Okay, number 12. Write the inverse variation equation that would include the point 410. Well, that's easy. We know inverse variation. We know the form of the equation is y equals kx. What do I need to find? I need to find k. I know that x is 4, y is 10. So I'm going to have 10 equals k over 4. Solve for k. Multiply both sides by 4. You get that 40 is equal to k. It says write the equation. So your equation is y equals 40 over x. Done. Okay? If you can remember that you have to find the constant by multiplying x times y in a problem like this, go ahead and do it. Multiply 4 times 10. You have your constant and you know where it goes in the equation. That's totally fine. Or you just start with the equation that you know it has to end up in. So number 13, same type of question, except I want a direct variation. Remember, direct variation is y equals the constant times x. We need to find k here. So put the 4 in for x and the 10 in for y. So I have 10 equals k times 4. To get k alone, I've got to divide both sides by 4, right? 10 over 4 reduces to 5 over 2 equals k. I'm not done though. I have to write the equation, right? Remember, I'm replacing the k, the slope, the constant of variation, so I get y is equal to 5 over 2 x. So remember, if I ask you to write an equation, you're giving me the rule. The rule you're going to use for x and y. So you have to find that constant, that same thing that keeps popping up between all of the ordered pairs, right? So like you should be able to use this equation now to find any ordered pair on the line, or the other one for inverse would be on the curve. All right. So tables tend to really throw people. I'm asking you to decide if it's an inverse variation, a direct variation, or neither. And then if it's one of those, inverse or direct, I want you to actually write the equation. So for this, like what I find helpful is to think to myself, if these tables have a constant within them, then they're either going to be direct or inverse. So let's just take for a second y equals kx. Remember, that's direct. Inverse is y equals k over x, right? If you take these equations, like what we need to decide first is let's find the constant, right? So look at this equation for direct. To find the constant, remember the constant is going to be y divided by x, right? Because you just divide to get k alone, you divide by x. So that's how you find the constant with direct. For inverse, you're going to multiply. To get the constant, you're going to multiply x times y. So what we're going to do with this first question is we're going to say, will I get a constant if, let's check for direct first, right? So if I go and I do 3 divided by 1, what do I get? 3 divided by 1 is 3, right? If I do 5 divided by 2, do I get 3? No. 7 divided by 3, do I get 3? No. So in this case, if I divide y by x, do I get a constant? The answer is no. So it's not direct. So then let's go to inverse. If I find the constant by multiplying x times y, 1 times 3 is 3, 2 times 5 is 10, 3 times 7 is 21. Did any of those give me the same number? No. That means that there's not a constant within this. So this one is neither. It's neither, because if you divide y by x, you don't get the same number. If you multiply x and y, you don't get the same number, okay? The other thing you can do if you don't understand this way is you can just take these ordered pairs and plug them in to the equation and see if you keep getting a constant, okay? So let's try this next one. This next one, let's check for direct. So we're checking for direct to see if when I have the constant y by x, right? 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. 16 divided by 4 is 4. Did you just get a constant? Yes, the answer is yes, because a constant means you can do y divided by x every single time for every ordered pair, and you will still get 4, right? So since we did that, the constant is 4. So we're going to put that right here. So this we're going to say is direct, and the equation is y equals 4x, because it's direct variation, right? So remember, direct variation is that linear form. The k is really the slope, okay? The next one, if you take 12 divided by 1, you get 12. 6 divided by 2, you get 3. 4 divided by 3, you get 4/3 or 1 1/3, right? This one, if you divide y by x, you do not get a constant. So let's move on here. If I multiply x and y together, will I get a constant? 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. 4 times 3 is 12. Did I get a constant? Yes, I got a constant by multiplying, right? So remember, that goes with inverse variation, right? That's this. If you take these equations and plug them in for x and y, every single time you're going to get 12 for k, right? So here your constant is 12. So this is inverse, and the equation is y equals 12 over x. All right, so we are finished. If at any point you were like, whoa, something I'm a little unclear about, go back and watch that part of the video, or come ask me or your teacher. Come get help, or ask the person next to you. Like, get help. Good luck.